my pleasure to welcome you to tonight's lecture, co-sponsored by the Hope College Lecture Series and the Sustainability Office. Before I introduce tonight's speaker, just want to say a special thank you to students who are participating in my research study. I appreciate that. And just a reminder to you to leave after the lecture, before the question and answer time starts, and to remember to please fill out the post-treatment survey tonight. It's my honor to introduce to you today someone whose work I have been following and respecting for a number of years, and whom I am very delighted to welcome here to Houghton. Dr. Katharine Hayhoe is an associate professor of atmospheric sciences at Texas Tech University. She received her bachelor's degree in physics and astronomy, and a Master of Science and a PhD in atmospheric science from the University of Illinois. Dr. Hayhoe's research focuses on establishing a scientific basis for assessing the regional to local scale impacts of climate change on human systems and the natural environment. Her work has resulted in more than 100 peer-reviewed papers, abstracts, and other publications, including the U.S. Global Change Research Program's second and third national climate assessments. The list of organizations she either advises or serves on committees with is long and prestigious, and includes such names as the American Association for the Advancement of Science, the American Geophysical Union, the U.S. National Oceanic and Atmospheric Administration, and many others. She has also contributed her research toward and served as an expert reviewer for the Nobel Prize-winning Intergovernmental Panel on Climate Change. Dr. Hayhoe is widely respected by her peers not only for her world-class scholarship, but also for her ability to communicate the impact of climate change to a wide variety of audiences. Together with her husband Andrew Farley, Dr. Hayhoe published a book called A Climate for Change, Global Warming Facts from Faith-Based Decisions, the first book to address climate change from a uniquely Christian perspective. In 2014, she was named by Time magazine as one of the most 100 influential people in the world, an award I will gladly say she received about a week after agreeing to come to Houghton. But we are grateful. Her accomplishments go on, but I'll conclude by saying this. Communicating climate change, particularly within conservative or evangelical Christian audiences, is a complicated and challenging thing. Dr. Hayhoe not only brings to this conversation her knowledge as a world-renowned climate researcher, but also her Christian conviction that as Christ followers, we have something unique and distinctive to offer to this challenge, as a role founded upon hope and based on our identity in Christ. Please join me in welcoming Dr. Katharine Hayhoe.
I have to tell you that last April, which is when, let me lower this a little bit. Last April, which is when I heard the news about the Time honor, you always get these emails saying you've made this who's who list, pay $500 and be included in the book. I thought it was fake, and so I deleted the email. I'm used to getting emails like, you sent me, not those type of emails. So it actually took like a week or two before they sent a printed card saying, we really need to know if you're coming to the dinner. I was like, this is unusual. They don't normally invite you to a dinner. So I sent it to our communications office at our university. I said, I'm pretty sure it's fake, but could you just check into it? And about an hour later, they called back and were like, yeah, it's real. Anyways, I'm excited to talk to you tonight about my two favorite things, which are the science that I do and the faith that we share. I'm going to start off, not by talking about the science, I'm just going to start off with the faith. One of my favorite verses in the Bible is this verse from Hebrews. How faith is the substance of what we hope for and the evidence of what we do not yet see. If I were sitting beside the author of Hebrews way back when, I would have jogged their elbow and said, hey, you need the next verse there. Because really, science is the substance of things that we see here and now and the evidence of what we can observe all around us. So one question I get asked a lot is, do you believe in global warming? And my answer to that is no. I don't believe in global warming. There are many things I do believe in. I believe in God. I believe in the Holy Spirit. I believe in many of the same things that you do, but I do not believe in global warming. And Google backs us up on this. This is our Google definitions. It's amazing how close Google is to Hebrews. Bet you didn't know that. It defines define science as a systematic study of the world around us through observing and experimenting. Faith, on the other hand, is based on scientific apprehension rather than proof. So I don't see science and faith as being in conflict on this issue. I see them as two sides of the same coin. They do completely different things, but we need both of them. Now, I'm going to start with the science, and then go back to the faith. I'm going to talk about 4 questions. Now, I grew up in a church where you would have visiting preachers come. And whenever a visiting preacher came, they got to take over Family Bible Hour. And mostly they were respectful of the fact that it was Family Bible Hour. But some of them were not so respectful. And I still remember the one who went for an hour and 45 minutes. And then at the end of 45 minutes, you could tell he was wrapping up, winding down. And he got to the end, and he took a deep breath, and he said, "And now for part 2. And at that point, you just see everybody just kind of recognizing that Sunday dinner was gone, it was burnt. So I have 4 points, you know where I am. The first question is climate changing? And before we talk about whether climate's changing, let's just have a quick definition here. I'm not talking about weather. Weather is what happens in a certain place at a certain time. Weather is like a single tree. I'm talking about climate. Climate is like the forest. Climate is the long-term average of weather over at least 20 to 30 years. Now this is important because between the months of November and April, there is one question I get all the time. And it's usually accompanied by a look like this. It's freezing outside. Where's global warming now? How many people thought that this week? Yes. I drove down from Toronto, and it was even colder in Toronto than it was here. Here's the thing, though. There's a little thing called winter. And yes, it gets cold in winter, and it does snow. But whenever it happens, we're like, oh, it's so cold. Where's global warming now? It's because we are physical creatures, and we react very much to our environment around us. They did an experiment a couple of years ago where they took a group of people and they divided them in half. Half the people they put in a room that was slightly below room temperature, like 65 degrees. The other half of the people they put in a room that was slightly above room temperature, like 75 degrees. They asked those 2 groups of people, do you think global warming is real? Guess what happened? The people in the colder room were less likely to think it was real. That's how influenced we are by our environment. So what happens when we have a really cold winter outbreak like we've had this winter right this week and last winter we had in January? Just for an example, last January, this is what it looked like. It was very cold in the eastern half of the country, where all of our news outlets are located. So when people in Chicago or Atlanta or New York or Boston went to write a story, their story was about how cold it was. But at the same time, last year was the warmest year on record. That's the difference between weather and climate. It isn't just what's happening right here where we live. We have to look at what's happening all around the world. And it isn't just looking at this as a big issue in space, it's also looking at it over multiple years and decades. If you turn on the news or go to your favorite website, you'll hear people saying stuff like, it's not warming anymore, it's cooling. Global warming has stopped. Where do you get that from? Well, if you look at global temperature, and this is our global temperature, and you pick short periods of time, and you remember what is climate defined as? Climate is defined as the long-term average over 20 to 30 years. If you pick short periods of time, you can make the global temperature record do anything you want. You can make it go up or down or stay flat. But the reality is we can't just pick the pieces of data we like and throw the rest in the garbage. We have to look at all the data. When we look at all the data, here's what it looks like. The world is clearly warming, and isn't that crazy? Look at that. I just took the red parts out. Same data. The world is clearly warming. One year may be colder or warmer than the next, but over climate timescales, it continues. When we look across the whole U.S., we see that the U.S. is getting warmer. This is looking at the trend over the last 100 years. Some parts are getting warmer faster than others, and in other parts, like the Southeast, something else has been going on. Has anybody ever been to the Southeast, like Georgia or South Carolina in the summer? Anybody? Yes. What's the #1 thing you notice in the summer? It is humid, isn't it? The sweat just drips off of you. So in some places, it isn't just getting warmer, it's getting more humid. All that extra energy is going into evaporating more water. In fact, the world is about 5% more humid now than it was 50 years ago. We're seeing that our growing season has gotten longer. This is how many days our growing season has lengthened over the last 50 or 60 years. We're seeing that our heat waves are getting stronger and more frequent. This is a heat wave in Australia 2 years ago. It was so severe that they had to add a new color to their temperature map. That light purple in the middle is new. They never had to have it before. It's 54 degrees Celsius. That's 129 degrees Fahrenheit. Now that's just one heat wave. And one heat wave doesn't prove global warming, just like one cold snap doesn't disprove it. But what we see when we look all around the world over 20, 30, 40, 50 years is that the risk of these heat waves is increasing. We're also seeing that our heavy precipitation is getting more frequent, especially in the Midwest and the Northeast. And where we are is really kind of on the border between the two, isn't it? There's a direct connection between this and warmer air. Because when the air is warmer, what that means is more water evaporates out of our rivers and streams and lakes and oceans. So that when a storm comes along, there's more water available for it to pick up and dump. We're also seeing that our hurricanes are getting stronger. Now up here, you might not worry about hurricanes. Not really a thing you have to worry about up here. But down in Texas, where I live, hurricanes are a big deal. And we know that round about in June, the ocean starts to get warm enough to power our hurricanes, because we can't get hurricanes if the ocean is warm enough. And we also know that when the water gets warmer and warmer, it feeds the hurricanes more energy. And that's exactly what's happening. We're not seeing any more frequent hurricanes than we did 20 or 30 or 40 years ago, but we're seeing stronger ones because the ocean is warmer and it's feeding those hurricanes more energy and they're getting stronger. All around the world, we see changes happening. We see the center of blueberry production moving northward from Maine into Quebec because Maine winters are starting to get too warm for blueberries, if you can believe it. Probably the only thing in the world that it is too warm for. So we see these changes happening here. We see them happening on the other side of the world. In Kyoto, Japan, they've kept track of when the cherry trees have blossomed for over 1,000 years. They've kept track of the exact date because they have a festival. Those cherry trees are now blooming more than 3 weeks earlier than any time in the 1,000-year record. We're seeing that around the world, on average, every year since 1980, there's been about $5 billion in crop losses due to our changing weather patterns. And we're seeing our glaciers melting. This is a picture of a glacier from Glacier National Park 100 years ago, and today what they're still calling a glacier. These days, most of my colleagues are going to Glacier National Park for their vacations. The first time I heard of somebody doing that, I asked them, why are you going? Do you have family up there or something? And they said, no. They said, we're going to see the glaciers before they're gone. When we look around the world, we see evidence for a warming planet, not just in our thermometers, not just in our scientific measurements. We see it in 26,500 indicators. Many of them in our backyards. Trees blooming earlier, bugs moving north, snow melting earlier. 26,500 different lines of evidence from God's creation are telling us that the planet is warming. So the answer to the first question, is climate changing? Science says yes, it is. But then that begs a second question, doesn't it? If it is changing, why? Because we know, when we look to the history of the Earth, that the Earth's climate has changed before, right? It's changed because of natural cycles. It's changed because of different amounts of energy from the sun. There's natural reasons why the Earth's climate has changed. So we can't just immediately jump on the bandwagon and say, oh, it's got to be humans. We have to look at these natural causes first. It's kind of as if you went to the doctor with a bit of a sniffle and not feeling so good, and the doctor immediately said, it's Ebola. Not a very good doctor, right? You want a good doctor to say, okay, it's probably the flu. Oh, well, it isn't the flu, maybe it's an infection. Oh, it is an infection, maybe it's, you kind of go up the ladder before you go to the exotic and strange. So in the same way as a climate scientist, we don't immediately say, oh, this has to be human. We have to look at the facts first. So let's look at the sun first. If our planet were getting warmer because of a change in the energy from the sun, would that mean that the sun's energy would be going up or down? This is not a trick question. Give me a thumb. If we're getting warmer, would it be going up or down? Yes, all the students are brave enough and nobody else is. Shame on you, adults. You're right, it wasn't a trick question. So let's look at how that has changed. The purple line here is the sun's energy, and the orange line is the temperature of the Earth. Now, I don't know if you can see it because it's really faint on the screen, but there's a thin purple squiggly line there that goes up and down. So there's an 11-year cycle in the sun's energy. But long term, you can see that it peaked and it's been going down. So while the Earth has been warming more and more over the last 40 years, we've been getting less energy from the sun. So it can't be the sun. The sun has an alibi. Now, what about natural cycles? We know that there's big natural cycles in the Earth system, like El Nino and other things. It means that sometimes it's wet over here and it's dry over there, or sometimes it's hot over here and it's cold over there. Because all of these natural cycles can do is move heat around. Can't create it or destroy it. All it can do is move it around just like a teeter-totter or a seesaw. Just out of curiosity, how many people call this a teeter-totter? A lot. Okay, seesaw? Any seesaws? See, I can't figure out why we use the two different ones. I cannot figure it out because it's always about 50-50. If you find out, let me know. I seriously want to know. So whatever you call it, a teeter-totter or a seesaw, that's what a natural cycle is. It just moves heat around the Earth system. So if our entire planet's atmosphere is warming, Australia, the Arctic, China, England, United States, if the entire atmosphere is warming due to a natural cycle, where would that heat have to be coming from? I'll give you a clue. It's not a trick question, and the answer's on the slide. Yes, I hear people whispering. Yes, the ocean. That's the only really other big place that we have enough heat stored. So let's look at whether the heat content of the ocean has been going down while the heat content of the atmosphere has been going up. Because if that's been happening, then that's what's causing our warming. Here we go. What you're looking at here is you're looking at the change in the heat content of the atmosphere, land, and ice. That's the green, all put together. And the blue is the change of the heat content in the ocean. And this is in exajoules. Wouldn't you like to measure your calorie intake in exajoules? Makes you feel very thin. 8.0000001 exajoules when I stopped at Tim Hortons today. Do you have Tim Hortons south of the border here, or is it just north?
Yes.
You do? Okay, excellent. When we look at this, this is actually, I think, from the perspective of a climate scientist, this is one of the scarier plots I've seen, because this says that the warming we see in our air around us is literally the tip of the iceberg of global warming. 20 times more heat has been going into the ocean than into the atmosphere. It's just that we don't live in the ocean, so we don't look at it very much. So this is not a natural cycle, because from the bottom of the ocean to the top of the troposphere, the entire planet is warming. Now there's one more big reason why climate has changed in the past. And that big reason relates to the squirrel chasing the nut. Remember? Broke off the ice sheet, triggered the end of the whole ice age. Anybody seen that movie? Yeah. Yes. Not really the squirrel, no. But we all know that there was an ice age. In fact, it was really interesting driving down from Toronto, because where Toronto is very flat, because that's where all the deposits came from when the glaciers melted, and then you get into upstate New York, it's very nice and hilly. So you can even see the remnants of the ice age in the world around us where we live right here. We know something very interesting. We know why those ice ages happen. We know that thanks to a Serbian engineer who was put in a work camp during World War I. This is crazy. So during World War I, this Serbian engineer was put in a work camp, and it actually sounds like a perfect camp for engineers, because apparently the man had unlimited free time, pencil, and paper for 3 years. In fact, it sounds like an engineer's dream. More engineers might like to be put in a camp like that. And so there he was in this camp thinking, what can I do with myself for 3 years? He probably didn't know it would be 3 years at the time, but he knew he was there for a while. He said, I'm going to figure out from first principles using basic mathematics why the ice ages happen. And he did. He figured out that because the Earth shape over time. It becomes more circular, and then it becomes more elliptical, and then circle again. And also the tilt of the Earth's axis changes over time. So the North Star today is not going to be the North Star 10,000 years from now because our axis changes. He figured out that because of these periodic changes in the Earth's orbit, and because the Earth is part land and part ocean, it changes the way sunlight falls on our Earth. And whether more sunlight falls on the land or the ocean makes a difference in how warm we are. So that's why these ice ages happen. So you may say, well, aren't we just getting warmer after the last ice age? No, we're not. The warming from the last ice age peaked 8,000 years ago. And since then, if you look at our Earth's temperature, this is looking at the last 6,000 years. Earth's temperature is red, and carbon dioxide levels, which we'll talk about in a minute, are black. If you look here, you can see that our Earth's temperature has been slowly cooling for the last 6,000 years. And if you do the math that the Serbian engineer discovered back in World War I, the math tells us that the next thing on our geologic calendar is the next ice age. Isn't that crazy? Now, when I say the next thing on our geologic calendar, I mean, I'm not talking tomorrow or even in 100 years. I'm talking long term. But that's what's coming next. Until when? Until something happened. The Industrial Revolution. So this is the situation we're in. It can't be the sun, because if it were, we'd be getting cooler. It can't be natural cycles, because the entire planet's warming. And it can't be the Earth's orbit, because the next thing coming is another ice age. So now we've gone through the flu, we've gone through the food infection, we've gone through all the usual suspects. Now we can say, is it Ebola? We know that during the Industrial Revolution, we started digging massive amounts of coal and oil and eventually natural gas out of the ground and burning it. We know this because we've kept really good records of how much of the stuff that we've used. And we know when you burn a certain amount of coal or gas or oil, it produces carbon dioxide. Because these fuels have carbon in them. When you burn them, it combines with oxygen and it goes into the air, right? Why do we care about carbon dioxide? We care about it because our planet has this amazing natural blanket of carbon dioxide, methane, water vapor, and other heat-trapping gases. Here's how this blanket works. The sun's energy shines down on the Earth, and it goes straight through these little gases. These little gases are completely transparent, just like a window to energy from the sun. The sun's energy comes down and heats the Earth. The Earth heats up and gives off heat energy, just like our bodies. Here's the cool thing. You see those little gases? They are opaque to heat energy. So they act just like a blanket does on a cold night. How does a blanket keep you warm? Now don't be fancy, I'm not talking about an electrical blanket. I know somebody was thinking that. How does a regular blanket keep you warm? Traps your body heat, right? That's what this blanket does. It traps the Earth's body heat. And this blanket keeps us 60 degrees warmer, almost, than we would be otherwise. If we didn't have this natural blanket, we wouldn't be sitting here today because the Earth would basically be a frozen ball of ice. Now, I know when you go outside, it feels like it is a frozen ball of ice. But trust me, in Texas, it was 80 degrees last week. Yes. So what's the problem? Because this is totally natural, right? This is completely natural. The problem is that we are adding to this blanket. We have increased the levels of carbon dioxide in the atmosphere 43% since the Industrial Revolution. When I used to go stay with my grandma when I was little, up in Toronto, my grandma was scared to death that we would freeze at night. So we would go to bed, and I would say her house has central heating. It does, with a thermostat that worked. But we would go to bed, and then Grandma would sneak in at night, and she would put an extra blanket on us. And we would wake up in the middle of the night going, Grandma, you did it again! Because we were sweating. We didn't need that extra blanket. That's what we're doing to the Earth. Through burning all this extra coal and gas and oil and putting putting all this carbon dioxide in the atmosphere, we're adding this extra blanket to the Earth, and the Earth is heating up. So why is climate changing? Science tells us it's got to be these increasing levels of heat-trapping gases because every other reason has an alibi. In fact, I have a colleague who did a study saying, if there's something we don't know about, if there's a reason we don't know about, how much of the warming could be due to that reason we don't know about? It turns out that less than a quarter of the warming could be due to something we don't know about. Because then you have to explain how these gases are not doing their heat-trapping thing. If that makes sense. Here's the thing. The science that I've just showed you, how long do you think we've known about this science? Maybe 10 years? Maybe 20 years? The science I just showed you was discovered by these guys here. And these guys are not dressing up in old-timey costumes to have fake photos taken. They really are that old. This natural blanket our planet has was discovered by Fourier, the same Fourier who did all that math that you learned about and probably hate. Same guy. Irish chemist here, Tyndall, was the first guy to figure out that mining coal produced more of these gases. The man in the middle, a Swedish chemist called Arrhenius, he was the first person to calculate how much the Earth would warm if we keep on putting carbon dioxide into the atmosphere. He calculated the first climate model by hand in 1890. It took him 2 years, and his wife left him. Nowadays, we have computers to do the climate modeling, so we can stay married. Not kidding. This man here is a British engineer. He was the first person to measure how much the world was warming because of what we're doing to it. And this man here, Charles Keeling, was the first person to start measuring carbon dioxide on a monthly basis at Mauna Loa in Hawaii, and it continues today. But you may say, okay, well, this is all very well and good, but I can go to the Washington Post or the Wall Street Journal just about any week it looks like, and I can find headlines like this. The science isn't settled. We don't have enough information to really make up our minds on this yet. And when we survey people, just people in general think that scientists are 50-50 on this issue. Why is that? It's because when we turn on the TV, there's one head saying it's real, and there's one head saying it's not. There's one head saying it's serious, and there's another talking head saying, it's no big deal. So we have been told implicitly that the science isn't settled, it's still 50-50. Let's just let those guys figure it out, and we'll come back in 10 or 20 years and maybe they'll have made up their minds. Here's the thing. We've already made up our minds. The reality is that over 97% of climate scientists don't just agree that climate is changing, but that humans are the main reason why it's changing. And when we go to the scientific literature, the difference is even more stark. From 1991 to 2012, there were almost 14,000 scientific studies published showing us that climate change is real and human-caused. In comparison, there was 24 saying that it wasn't. So that's why we're in this situation today. 97% of climate scientists say it's real. 97% of doctors say that we have this new condition that nobody's ever had before, but they're sure we've got it this time, and this is what the treatment is. And not only that, but here's one more thing. You may say, well, okay, so scientists are sure that it's real, but we all know that they're exaggerating it to get funding, as if the funding somehow funnels into our bank accounts. I can tell you it doesn't. So if you want to be a scientist to get funding, don't do it for that reason. So a study, this is what I love about science. There was a study to test that. This came out 2 years ago. This study tested whether scientists are alarmist by looking at the last 20 years of projections and saying, did scientists overstate the risk? Well, here's what this study found. It found that far from being alarmist, scientists have in fact been conservative in their projections, consistently understating what has happened so far. And in fact, the study concluded that scientists are biased towards being cautious. And, this is what I love, the study actually coined a new syndrome and said that we've got it. We have ESLD, We err on the side of least drama. In other words, instead of being drama queens, we scientists are like anti-drama kings? I don't know. So not only do scientists agree, but when you see a scientific result on climate change, this study is saying, take it with a grain of salt. A grain of salt that it is likely to be more cautious and more conservative than reality. That is not good news. I know there's a lot of other questions on the science that you may have. What about volcanoes? What about the ice cap on Mars? What about those scientists and their stolen emails? And so I want to leave you with a great resource before we move on. This is one of my favorite websites. It's called skepticalscience.com. It's the brainchild of a scientist and a fellow believer named John Cook, and it answers just about every scientific question we can have about climate change. Here's the thing though. The science can tell us that climate is changing. The science can tell us why it's changing. But now we start to move from what's in our heads to what's in our hearts. Why do we care about this issue? Because if I say climate change, or if I say global warming to you, what's the first picture that comes into your head? This is the #1 image people most frequently associate with global warming. And I'm sorry, but if we are being asked to change the entire way we get energy just for the sake of the polar bear, I'm going to be totally honest, put him in a zoo. Make a big zoo. Make half of Alaska into a zoo. There's plenty of Alaska out there. Heck, we'd even probably donate half the Northwest Territories to the zoo, if that's all it takes. So one of the greatest myths we have been sold is that climate change is a distant issue that only matters if you live up in the Arctic, or maybe if you live on a low-lying island in the South Seas. We've also been told something else, that climate change doesn't really matter to us here today, it matters to our grandchildren, or their grandchildren, far in the future. Here's the thing. The impacts are not distant in space, and they are no longer distant in time either. Today, we are already seeing more heavy downpours and flooding. We're seeing more frequent snowstorms, because what happens when all that water evaporates and the storm comes by and it's below freezing? As it is often in winter, it snows. We're seeing stronger hurricanes, we're seeing really bad heat waves, we're seeing all of these things happen today. And why do we care about them? We care about them because of an assumption that we don't often think about. We assume that we can have hot and cold, we can have wet, and we can have dry, but we assume that long term it's all going to average out. This is the assumption that we use when we build our buildings, our homes, our roads, our infrastructure, when we plan for how much water we're going to use in the future, or how much energy we're going to need, or even where we grow our food. This is the assumption that we count on. What happens if this assumption is no longer true? At the same time, though, you will then hear people saying, so what? It could be good. You know what? We actually need more carbon dioxide, not less. It's plant food. Climate change is good for the world. Look how happy this polar bear is surfing down the wave on a melting iceberg. The baby polar bear doesn't look so happy, but the mama does. Where do these articles come from? Let's dig into one of them just to kind of give you an idea. Here's an article that came out last year. I love it because they packed so much into the title. World is doing just fine. Global warming is good. CO2 is our friend, say scientists. Hang on a second. Didn't you just say that scientists are saying that it's bad and they're not even saying how bad it is and they all agree? Well, who are these scientists? Well, the article starts off by saying the verdict is in. The news is good. Animals are thriving, humans are doing better than ever, and it's all thanks to CO2 and global warming. Who's saying this? Next paragraph. This information is coming from an independent research body funded by the Heartland Institute. It's not coming from scientists in labs working for a university or a government organization. It's coming from an independent research body funded by the Heartland Institute. Well, maybe they're scientists. Let's see. Go to Wikipedia. I like Wikipedia. These are all direct quotes from Wikipedia. The Heartland Institute is a public policy think tank which advocates free market policies. Doesn't sound like science. In the 1990s, the group worked with the smoking industry to question the connection between smoking and cancer. More recently, they focused on questioning the science of climate change, and their major sources of funding consist of oil and gas companies. When we talk about climate change, when I talk about everything I showed you before, here's the data that we're using. When you see articles like this, there's not a lot of data in them. But unfortunately, these days you can say almost anything you want. So rather than being the happy mama polar bear, it's more like the baby polar bear at the bottom going, this doesn't look so good, because this is the slope that we are going down. Why do we care if climate isn't stable? Why do we care if the risks of extreme heat waves are increasing like we've seen? We care about heat waves because it affects our health. In 2003, they had a heat wave in Europe. Now, I recognize 2003 was a long time ago. It was, gosh, it was 12 years ago now. In that heat wave, 70,000 people died. 70. Scientists calculated that the risk of that heat wave had already doubled because of climate change. In other words, that heat wave was like rolling a double six. Climate change had already taken some of those other numbers off and started replacing them with sixes too. So now the risks of getting that really bad heat wave are increasing, as are the risks of getting that really bad heavy downpour or flood, like we've seen in North Dakota in many recent years. Like we saw where I live in Texas just this September. This is our football stadium here, and this is a freeway. Cars underwater in the freeway in Texas. Isn't that crazy? It's also even changing our risk of lake effect snow. Why is that? It's because when do you get lake effect snow? You get lake effect snow when a cold air mass sweeps over Lake Erie when there's no ice on Lake Erie, right? That's when you get lake effect snow, because then the cold air mass picks up all the water and dumps it where? On you. Or just a little more. I grew up, growing up just north of the border, we always used to watch for lake effect snow, and then we'd head to Kissing Bridge. And I remember one time, I don't know if they still have it at Kissing Bridge, but they had these little tiny pommel lifts that would take you up through the woods. And if you're horsing around with your friend, as maybe some of us would, and you lose your grip on the pommel lift, you are in the woods in like 5, 6, 7 feet of snow, and there's no way to get out. So I have many personal experiences with lake effect snow. Anyways, we have seen over the last 50 years that the risk of lake effect snow is going up as it gets warmer. It's because the number of days when Lake Erie is not frozen, but there's a cold air mass sweeping over it, are going up. Because the Great Lakes are not freezing as much as they used to. We're also seeing hurricanes getting stronger. Now, with Superstorm Sandy, which is, you're seeing the after effects up here, was Superstorm Sandy that unusual? It actually wasn't, because about once every 5 years, a big tropical storm gets all the way up to New York in the month of October. So Sandy in itself was not unusual. What was unusual was the fact that the water off the coast of New York was almost 5 degrees warmer than average. So what does that mean? It means that it fed the storm extra steroids, or Wheaties, depending on how you like to look at it. What was also unusual was the fact that ocean water is already 8 inches higher than it would have been 100 years ago. So some areas were flooded that would not have been flooded if Superstorm Sandy had occurred 50 or 100 years ago, and also because the storm was stronger than it would have ordinarily been. So in the U.S., on average, we have maybe 1, 2, sometimes $3 billion disasters every year. The last few years, we've seen more like 8, 10, 12. And we're seeing it going up around the world, too. And that's why insurance companies are one of the first to care about climate change. So why do we care about this issue? The science tells us that climate change is going to affect our quality of life, our resources, and our economy. There's very practical reasons to care about climate change. Here's the thing, though. It's not just about what matters to me, my family, and my community, is it? As Christians, we're called to love others, and others may not necessarily be the people sitting beside us here. Maybe the people who don't have enough down the road, on the other side of the country or on the other side of the world. When we look at climate change, we can see that our carbon emissions over the last 100 years have come from certain countries, and we can see that the impacts of climate change are being experienced by pretty much the opposite set of countries. When we look at this, we say, this is not fair. Because as sea level rises, for example, in Florida, we stand to lose most of the Keys and half of the Everglades. But in Bangladesh, they stand to lose half of their rice-growing area. We stand to lose Glacier National Park, but 1 billion people around the world stand to lose their supply of fresh water. This is the glacier that supplies the city of Lima, Peru, 8 million people with 2 inches of rain a year. They've been using this water for so long that some of it flows through irrigation channels built by the Incas. This glacier has receded so far now that they can't use it anymore. So a couple of years ago, they built a desalination plant. But desalination is a lot more expensive than free water from the glacier. There's all kinds of climate witness programs out there that go and talk to people, like this man, Augustine, who says, there's 2 seasons where I live. There's the dry season and the wet season, and that's how we farm. In the days of my childhood, the wet season was very clear when it was coming, so we knew when to plant. The rains were predictable. Farmers knew what to do. But now the goalpost has shifted, and over the past 20 years, it's become increasingly difficult to predict when the rainy season's coming. Even when the rains start late, they're more erratic. There's like feast or famine, flood or dry. We don't know what to do here. Animals are having to travel too far to get water, and sometimes they die. And he concludes, it is my conviction that explanations to such outcomes are connected to climate change. So this raises a whole different issue, doesn't it? It's not about me and my family and my community. It's about what is happening to other people as a result of our actions. So one of the reasons why I love participating so much in the show, The Years of Living Dangerously, is because it puts a human face on climate change. You can download this, I think it's about 5 or 6 episodes. You can download them from iTunes, or you can watch a bunch of stuff for free on YouTube, including the whole first episode. And it goes around the world talking to real people who are being affected today. So why do we care about climate change? It isn't just because of our selfish reasons, it's because our faith tells us that climate change, if it's impacting our neighbors, we are told to love them. Last question. What do we do? Okay, so climate is changing. So it looks like humans are responsible. And there's plenty of reasons to care, not just for myself, but as a Christian, caring for others. But I'm just one person sitting here. What can I do? The first thing we have to realize is that our choices do matter. We've already seen a certain amount of climate changing today, but what's going to happen in the future is going to look radically different, depending on whether we continue to depend on coal and gas and oil for our energy, or if we can transition in a sensible, sustainable way to other ways of getting energy, like Houghton College is doing very soon. Our choices matter, but there's a lot of barriers in the way. What type of barriers am I talking about? All kinds of barriers. Just to give you an example, barrier number 1 is the fact that we are getting false information fed to us on a regular basis by people we trust. We are. This is a book, Merchants of Doubt, that's coming out as a movie next month. So if you have a chance, I doubt it's coming to Houghton, but it probably is coming to Buffalo. Or it'll be on Netflix soon. There are people who used to work for the tobacco industry, who when the tobacco industry conceded that cancer was a byproduct of smoking, said, oh, well, who can we work for next? Let's work for people trying to prove that climate change isn't real. And there's people out there who are professional merchants of doubt who are making up information and feeding it to us through people that we trust. Not only that, but we also have to recognize that we're not asking for a small change. We're not asking people to just start recycling one extra type of can. We are asking for a change in the fabric of our society of the same magnitude as the change from slavery until now. If each of us depended on slaves for our energy right now, do you know how many slaves we each need? we would need 200 slaves bicycling 24 hours a day to supply our energy needs. Now, if they were Lance Armstrongs, maybe only 60. They tried it with a house in England. Unbeknownst to this family on a Sunday, they unhooked them from the grid and they hooked them up to a bunch of cyclists pedaling on stationary bicycles to see how many it would take to power their home. We aren't asking for a small change. We ask our organizations, our institutions, our universities to divest from fossil fuels. Not only that, but we perceive the risks of the impacts to be distant and small, polar bear, versus the solutions to be costly and expensive. I just gave a talk in Texas last week, and a man stood up at the end of the talk and he said, well, you know, all that you said sounds good and fine, but I don't want the government telling me what temperature to put my thermostat on. I said, well, I don't want the government telling me that either. But that's what we hear as a solution to this problem, and nobody wants the government telling them what to do. So a lot of what we hear is scary. A lot of the solutions we hear to climate change are scary. They involve words like taxes and legislation and restrictions and cutting down and doing with less and reducing and bad words that we don't want. So here's where our faith comes in again. This is my second favorite verse in the Bible. In Timothy, it says, God has not given us a spirit of fear. So when we hear messages coming at us that are full of fear, fear for the future, fear of punitive restrictions, fear of government action, these messages are not coming from God because God has not given us a spirit of fear. What has God given us? God has given us a spirit of power. God has given us a spirit of love. And this is my favorite one. God has given us a sound mind. How's that for awesome? We have been given a brain to make good decisions. So when we look at the issue of climate change, one time I had somebody tell me that every time you get in a car and you turn it on, you are committing a sin. And I'm going to be totally honest with you, I just wanted to go out and find the biggest old car I could and just drive in circles around him. Because nobody likes to feel like they're committing a sin when they're driving their child to school or they're going to church in the morning. I don't think of this as a sin issue. I think of this as a fact that our choices have consequences. And way back when, 300 years ago, when the Industrial Revolution was starting, we didn't know that digging all this stuff out of the ground and burning it was going to be wrapping an extra blanket around the earth that would be changing our weather patterns. We didn't know that back then. And the Industrial Revolution has brought many advances, right? We wouldn't be sitting here today if it wasn't for the Industrial Revolution. And I don't think I'd be alive today if it wasn't for the medical advances that have come with the Industrial Revolution. So it was a good thing. But choices have consequences, and now we know, today we know, that we need to start doing things differently. This is a quote from one of my fellow scientists who said something really interesting. He said, at this point in time, we have 3 choices in front of us, and basically, let's make a good one. We can reduce our carbon emissions, we can prepare for a different future, or, and this is not a sciencey word, in fact, this is the first time I ever heard a scientist say this, we can suffer. We as Christians know all about this, though. We're going to do some of each. The question is what the mix will be, because the more we reduce our emissions, the less we have to prepare for a different future, and the less suffering there will be. So what do these 3 choices look like? There's all kinds of fun examples, but I'll just give you 3. In the Netherlands, most of the Netherlands is either at or, in some cases, below sea level, right? And we expect sea level to increase 2, 3, maybe even 4 feet this century. So what are they doing? They're building floating villages. What happens if sea level goes up 3 feet? Put 3 more feet on the anchor chain. Big deal. Isn't that awesome? And besides, people want to live in a floating house. We know that cities like London and New York, 2/3 of the world's biggest cities, are within a few feet of sea level. We know that these cities are really worried about storm surge. So they're building barriers so that when those storm surges come, they can close off the channel and they won't be flooded. We're also reducing our carbon, and this is a picture from Texas. This is a picture about an hour away from where I live, where we see old rusting wind turbines being replaced, old rusting oil rigs being replaced with shiny white wind turbines. Are these going up on the land of farmers and ranchers who are tree huggers? No, there's no trees to hug in Texas. They're growing up on the land of people who just want to make money and invest in the local economy. So a couple of years ago, I went down to a little town in Texas, and there was a farmer there who his neighbor had wind turbines up until the border, but he didn't have any wind turbines. He had a couple of old oil rigs on his property. So after we'd been chatting for a while, we discovered that somebody from my church knew somebody from his church, so we were kind of connected. I got up the courage to ask him, is there a reason why you don't have any wind turbines? Because I noticed your neighbor has some. And he said, yes, there is. And I was expecting, those tools of the devil type of thing. He said, there is a reason. It's because I got on the list after my neighbor. I've been waiting 2 years for my wind turbines. I said, well, why do you want wind turbines so much? He said, well, because the check arrives in the mail every month. And he says they're better than oil rigs because those oil guys are driving in and off my land all the time, messing up my roads, getting the oil. But those wind turbines, they set them up once. You never see them again. They control them from Florida. All you see is the check in the mail. So you may say, at this point, okay, that sounds great. I'm glad that even Texas is using wind energy. And in fact, last spring we broke the record for over a third of our electricity coming from wind in Texas. But what about China, right? Because we all know China is building a coal plant a day. We know that the air in Beijing is so terrible that it cuts 5 years off your life if you live in Beijing. What about China? Here's what about China. Prepare to be shocked. China is #1 in the world in wind energy. They have 50% more wind than the United States does. China is #2 in the world in solar energy after Germany, and the US is #5. China has a plan to peak and begin to phase out coal use in 5 years. So yes, China is awful now, but China is eating our butts in renewable energy and the clean energy economy. It doesn't have to, though. This is one of my favorite factoids. Texas has enough solar potential to power the entire world if we just use it. You may say, though, that solar power is so expensive. Well, here at Houghton, we know it isn't because you're putting it in. But just to show you why you're doing it, this is the price of solar energy over the last 25 years. That little green bar there is the price of energy from natural gas. We are so close to this stuff being the same price as that old stuff we use. It's like the new iPhone 6 being the same price as the old iPhone. Wait, it already is. Why are we using the iPhone 1 when the iPhone 6 is available? My husband loves getting new gadgets, and I remember a couple of years ago when the iPhone 4 came out, because that was like the next big thing. He just got one of the first iPhone 4s, and we came home to Toronto for Christmas. It had not yet come out in Toronto. It was coming out that next week. We were in the shopping mall, walking past the Apple store, and there was a lineup of 200 people coming out of the Apple store waiting for the iPhone 4. So you know what my husband does? Pulls out his phone, walks down the row. Yes. His point. Why would you go for the old one when the new one's right here? So that's why I feel like talking about this is really, it's a message of hope. It's not a message of fear and depression. It's a message of there is a better world out there. We are already moving in the right direction. We just need to recognize it and do more. So what can we as individuals do? The first thing we can do is really simple. We can measure our carbon footprint. What do you do if you're going to lose weight? Not that anybody here needs to lose weight. Maybe just me. If you're going to lose weight, what's the first step? Step on the scales, right? Because unless you step on the scales, how much are we going to lose? In the same way, the first step to doing anything about this issue is just to measure our carbon footprint. Because until we know where all our carbon comes from, how do we even know what to do? For one of us, maybe eating 1 day less meat a week would be the most effective thing that we can do. For maybe another of us, maybe replacing a light bulb can be the most effective thing we can do. For every light bulb we replace, we save $30 over the lifetime of the bulb and saved energy costs. And if every household in the U.S. replaced one light bulb, that would be like taking 1 million cars off the road. That's how effective this is. But even though we as individuals control over half of the choices that make up the U.S. emissions, we don't control a lot of the choices. And so that's why one of the organizations I volunteer with is called Citizens Climate Lobby, because this is an organization that helps ordinary people. It's not a bunch of special people. It's started by a real estate agent It involves a lot of teachers, parents, retired people who just want to tell people in charge of our community, in charge of our state, or even in charge of our country that we care about this issue. So going back to the issue of faith and science, I think that faith and science are totally different but totally necessary. Because in the case of climate change, science can tell us it's real, science can tell us why it's happening, science can tell us if we decide to do this, here are the consequences, if we decide to do that, here's the other consequences. But science can't tell us what to do, can it? No. That's where our heart comes in, and that's where our faith comes in. Nearly all of us, I think, would agree that God created this planet, and it's good. That God gave it to us to care for. And whether you use the word stewardship or dominion, I think it comes out to the same thing, because if you have dominion over a large company, and you run that company into the ground and destroy it, what does that say about you? In the same way, if we've been given this earth to care for and we run it into the ground, what does that say about us? What does it say about us when we take the most amazing gift from somebody and we treat it like trash? It says that we're not really respecting the person who gave us that gift. But not only that, it's not about the planet, it's about people. The reason we care about climate change is because it is affecting real people today. And we are told to love God and to love our neighbors. So what can we do? I believe that our faith tells us that the only thing that counts is faith expressing itself through love. And this issue of climate change offers many opportunities to love others here at home and around the world. Thank you.
We're going to have question and answer time. Before we do that, students who are participating in the study, if you can go ahead and be dismissed. If you really want to come back to that, you brought something through, you can do the post-test survey real quick out in the lobby and come back in this one. Thank you. If you have questions, please feel free to hang out. I'm sure some of you have them. And we'll take your questions for about the next 15 minutes. And I'm just going to ask those of you who have questions, go ahead and raise your hand up and stand up and say your question so that we can all hear you a little bit better. Dr. Hago is going to respond.
Yeah. And I'll say the question again so that people can hear what you're saying. The reason why some people have to leave is because there's another whole group of students who are watching a video. It is almost the same as this presentation, but has some slightly different content. So we can't have some students hear the questions and others not, because then we would be getting extra information, in case anybody's wondering. I don't think Houghton College is anti-student questions, is it? No. Okay. Questions? This is your opportunity. You can get a word in twice. Any questions? No questions. Yes, go ahead. That's a great question. Whenever organic material decays, it produces methane, which is a heat-trapping gas. In fact, methane is 35 times stronger a heat-trapping gas than carbon dioxide. So the question is it better to compost, or is it better to let stuff be taken away and put in a landfill? Something that a lot of people are starting to do these days, which I think is really smart, is sticking a pipe on our landfills. Because as organic material decays, it produces methane, and methane basically is natural gas. Natural gas is 96% methane, roughly. So we can burn this stuff, and in fact, farmers, if you collect all of the manure and you put it in a digester, it just basically turns into natural gas. So if we are trapping it, if it's going to a landfill where it's being trapped, that's great. But if it's going to a landfill where it's not being trapped, then we're better off composting ourselves and using that compost for something and letting the methane go into the air because it will anyways. Yeah, but that's a great question. And that shows how often stuff isn't black and white, right? I mean, is it better to, is it better to spend more money and buy a new car that's more efficient, or is it better to not buy a new car and use the old one we have rather than getting all those new materials to make a new car? So there's a lot of different choices, and that's why I love the carbon calculators. And I should say there's other carbon calculators. You don't have to use this one. If you just Google carbon calculator, you can find some other ones too. I love them because they get into those trade-offs. And based on where we live, how many people we live with, what kind of climate we live in, how far we travel, that type of stuff, it gives us suggestions specifically for us. Great. Now that she's cracked the ice, any more questions? That was not a stupid question. That was such a good question. I'm sure people are like, oh no, I can't get a good one yet. Any of us? Yes? Sure.
Yeah. How much carbon metric tons do we need to reverse in order to see this reverse trend? Do you understand the question?
Yes, I absolutely understand the question, and that is actually the topic of some research I have done trying to answer that exact question. Here's the thing. So this is looking at our change in global temperature depending on the choices we make. In order to achieve that green line, our carbon emissions have to peak and decrease to below 1990 levels. So in other words, for temperature to plateau, our carbon emissions have to peak and go down. The reason why is because it's like a bathtub. You guys are so fast. That was awesome. It's like a bathtub. If you have a bathtub with a clogged drain and you're pouring water into that bathtub, right now, the water is the carbon emissions. Right now, we're turning the tap up and up and up and up and up. So there's more and more and more water pouring into the bathtub. So the bathtub's rising faster and faster. If we take our hand off the tap, but it's still on, the carbon emissions are steady, the bathtub is still filling up. To get the bathtub to stop filling, we have to stop our carbon emissions. To get the bathtub to go down, we have to figure out a way to get the carbon out of the atmosphere. And people are working on that. They've discovered a certain type of mineral that if you grind up, it acts just like that stuff does in babies' diapers. You know the stuff in babies' diapers that bonds with water? So babies' diapers don't leak like they used to. They've discovered stuff that bonds with carbon dioxide just like that. It's just way expensive to do on a big scale. But they're trying to figure out ways to try to get the water out of the bathtub. But in the meantime, the first thing to do is to stop turning the water up. Is that, yes? Very good question. Any other questions? I should add, too, that I have a Facebook page where I usually try to post interesting information and answer people's questions, and I also am on Twitter if anybody does that. Yes, sir?
Have any ideas on how to counter opposition to alternate energy sources like windmills? That's been an issue in this area. People opposing windmills.
That's a tough question. Any idea on how to counter people's opposition to windmills? I talked earlier about how climate scientists are subject to the ESLD syndrome, the erring on the side of this drama. Unfortunately, we as humans are prone to the NIMBY syndrome, not in my backyard. And so when people talk about wind turbines, they say, oh, well, they're noisy, or they kill birds, or they look ugly. The reality is that cats, I don't know if you heard this, cats kill more than 100 times more birds than wind turbines do. So once we've gotten rid of Fluffy and Socks, then we can worry about the wind turbines. And if you think wind turbines are an eyesore, you've never lived beside a coal-powered plant. Here's the problem, though. This is, again, where our faith comes in, not just our science. Where are these ugly oil refineries and coal plants usually located? They're located in poor neighborhoods where people can't afford to move away, and often can't even afford insurance to cover their children's asthma costs. So we're used to living in a world where the poor and the disadvantaged and the people who do not have voices are bearing the costs of our energy and our economy. So sure, I mean, not everybody might want a wind turbine in the backyard, though I actually do want one. But we have to realize what is the alternative, and just because we've always done it that way, some of the most dangerous words in the English language, just because we've always done it that way doesn't mean it's right. Hope that helped. By the way, incidentally, I also heard, sorry, just a second, there's people at my university who do research on bats and also on birds, and they've discovered that if you paint the wind turbines purple, then the birds and the bats avoid them. Here's the problem, though, most people don't want purple turbines. Yes?
How much would stopping deforestation and proposals for reforestation change the scenario?
That would help a lot because that would be a huge component to taking carbon dioxide out of the atmosphere. A low-tech way to suck that stuff out, in answer to your question, is to plant a ton of trees. And so that is one way that has actually we've been working on. In fact, deforestation rates in many countries around the world have slowed, which is great. And at least up in Canada, we plant a ton of trees. I feel like every friend I had in high school went tree planting at least once in the summer. So tree planting is a great way to suck that carbon back into the biosphere where it's supposed to be. Yes?
Another question. So during the Pennsylvanian and the Mississippian period, when all of our coal deposits were created by equatorial forests going down into swamps and being compacted and covered, would we be able to somehow recreate those carbon deposits by redoing all of the forests and then burying them?
Oh gosh. I think there's a Hollywood movie plot in that idea. Could we make coal deposits? There are definitely attempts underway to try to sequester carbon dioxide underground in old reservoirs of gas and oil. The problem, though, is that it's hard to keep the stuff down there. So there's plenty of very creative ways to do it. But the short answer is it's easier to not produce it in the first place than it is to produce it and then try to suck it out of the atmosphere. So there are a lot of creative ways that people are thinking about it, but we can't use those as a fix-it Band-Aid. We have to reduce our emissions, and we have to try to figure out how to get the stuff out of the atmosphere. So, interesting idea, I like it. Any other questions? Yes?
There's some changes to the climate of the world that are already inevitable, like that there's no hope for it.
Yes, that's a good question. What are the changes that are already inevitable? Some amount of warming is inevitable, and if I go back to this figure here, you can see what I mean. So even if we reasonably peak our emissions and start to reduce them within a couple of decades, we're still going to see a certain amount of change. That's the green line there. And we're looking at up to a 4-degree Fahrenheit change in the temperature of the Earth. And just for reference, we've only seen 1.5 so far. So we're still looking at quite a bit of change. This means that several feet of sea level rise will be inevitable. It means that our average temperatures are getting warmer and also that our extremes are getting more frequent. So we're going to see more frequent heat waves, we're going to continue to see more frequent heavy rainfall and snow events. So a lot of the work I do is actually really interesting. I work with almost every federal agency. I work with DOD, I work with Department of Transportation, I work with the Fish and Wildlife Service. Because just for example, say you're trying to protect a certain species or a certain type of ecosystem, and you want to set aside a refuge to protect that. But climate is changing. So if you set aside a refuge here, in 50 years, that species will be 200 miles north. So what we do is we actually generate projections, that's my research, to say if you're trying to preserve the species, here's the corridor that you would want to set aside for that species, all the way up into here, because it isn't there yet, but it will be soon. With Department of Transportation, we're helping the engineers rethink the design standards they use. So instead of using design standards from 50 or 100 years ago, we're using design standards for 50 or 100 years in the future, so that when they build that bridge, it will be able to withstand the stronger hurricanes and the higher sea level rise that we expect in 50 or 100 years. Here's the coolest example. I work with a lot of cities. Right now I'm working with the city of Washington, D.C. and San Antonio in Texas. I finished working with Chicago a couple years ago. One of the things we found in Chicago was that they have really bad heat waves. In fact, they had a heat wave in 1995 that killed about 800 people just in Chicago alone. But here's the thing with cities. Cities have this thing called the urban heat island effect, right? Where it's nice out in the country, and then you go into the city and it gets really hot because of all the blacktop and all the dark surfaces. So we did a study for Chicago where we said, here's the risk of the 1995 heat wave coming back in the future. And it was quite high, very high in fact, almost basically inevitable. So here's what Chicago's doing. They're putting green roofs on their buildings to lower the urban heat island effect by the same amount that climate change is pushing their temperature up. Isn't that cool? So they're doing local climate modification to lower the risk of heat waves because they know that they're getting more frequent. At the same time, they're even saving money because putting a green roof on saves you in heating and cooling costs. So some amount of change is inevitable, but if we follow the green pathway, most of it we can adapt to. Not all of it. There's villages in the Arctic that are going to have to move today. They're already having to move. But most of it is we can prepare for if we know what's coming. The way I think of it is, in Texas, roads are very straight. And so between Lubbock and Plainview, Texas, is a dead straight highway. It is so straight that you could literally drive almost all the way to Plainview looking in your rear view mirror. That's how straight it is, and I'm not kidding you. Just before you get to Plainview, there is a giant curve in the road. And not only is there a giant curve, but there's this huge set of concrete silos right there on the curve. So if you miss the curve, you go right into the concrete silos. So the way it is, I think of climate change is, up until now, we've been building our buildings, growing our food, planning for our energy and water as if we're looking in the rear view mirror based on past climate. If we follow this lower pathway, and if we look ahead to see what's coming, we can successfully negotiate the curve. But if changes happen that are very large, if we continue on our current pathway, we will not be able to adapt to many of those changes, and we'll be in a triage situation, which nobody wants. Great. You have a question back there? Does somebody else have a question? I saw another hand go up when you did. Yeah? Okay. Any last questions? Yes?
So in West Africa, where the climates, or the weather patterns are current, is there a point where the plateau in carbon emissions or continue to go higher when the patterns stabilize? Because those farmers will be able to benefit from crops.
Yeah, that's a good question. So if the climate stabilizes, will we be able to predict the wet season, the dry season again? They just might be different times of the year. Yeah, part of the problem that we have right now is it's changing so rapidly. Over the course of Western civilization, we haven't seen such rapid changes ever. Now, sure, rapid changes have occurred in the past, but in the past, we didn't have 7 billion people living on the planet. In the past, if, say that sea level went up 2 or 3 feet 1,000 years ago, what would the Native Americans living on Manhattan Island do? Pick up your tent and move it, right? But today we have 2/3 of the world's largest cities within just a few feet of sea level. So the reason why we care about it today is because of that rapid change that we're not adapted to. So if we could stabilize climate, like under this lower scenario, then our climate would become more predictable. And it would be different, but it would be easier because we would know what was coming next. So yes, that would be great.
Time for one more question.
Yes?
I understand that you're working in the political science department and for various reasons and so forth. What are your thoughts about changing the belief system, especially within the evangelical Christian mindset, where many people, I think, have what they hold as a belief system that's true and dear to their hearts and related to issues of truth. And I don't know if that is an effect, but I would just be interested in what your thoughts are and your ideas for the future to encourage change.
That's a great question. Let me go back to this slide here. I am a scientist, so I come from a physics background, atmospheric science background, and a couple years ago I moved departments. I moved from geoscience to political science, and as with every decision, there's many reasons why you do that. But I'm glad I did, because I feel like the real roadblock on the issue of climate change is not the science. I feel like the roadblock is on our understanding of it and how we implement that. And so being in political science, I had the opportunity to not just do the good science, but also to figure out, well, what does this mean and how can we use it? So here's the interesting thing. When we do surveys of people and asking people what they think about climate change, the surveys break down like this. Here's what people unaffiliated with any Christian church think. They pretty much agree with the science. Here's what mainline Protestants think, a little bit less. Here's what kind of middle-of-the-road Protestants think, a little bit less. Here's what evangelicals think. Nobody thinks it's real. So evangelicals have a really bad reputation for not agreeing with the science of climate change. But here's the interesting thing. One of my colleagues, John Evans, who's a sociologist, did a study where he said, okay, is it really their Christianity that's making them not agree with the science? Because if you look at this, I think we're all pretty much on board with this. Like with other issues like creation and evolution and stem cell research and stuff like that, you can see why there's theological differences. But with the issue of climate change, there aren't really any theological differences. You could even say, well, does this challenge the idea that God's in control of the world? You could say. But no, because God gave us the ability to make decisions, and bad things happen every day as a result of the decisions we make. Does God stop every single drunk person from ever getting behind the wheel of a car? No. So God doesn't stop us from making decisions. It doesn't challenge his sovereignty. So the interesting thing about John's study was he controlled for a couple of things. And one of the things he controlled for was political affiliation. And he found that when you control for political affiliation, the bias against evangelicals drops out. So it isn't that evangelicals are predisposed to say climate isn't real, it's that people on the far right of the political spectrum are predisposed to say it isn't real. And many evangelicals either come from that area of the spectrum, or those are the people we trust. And those are the people we listen to. I went to a very interesting talk. I could talk forever about this stuff. You exactly touched on what fascinates me. I went to a talk by a political scientist from Stanford 2 weeks ago. And he talked about how our society has become so polarized politically over the last decade. It used to be that Democrats and Republicans were kind of like this, just quite close together. Not only have people moved apart, but we've become much more skewed out to the tails. So we are becoming so much more different. He said it's gotten to the point now where political affiliation trumps physical appearance and character in picking a spouse. Isn't that crazy? Why is that? He had a suggestion to offer. He said he thinks it's because nowadays we all have access to what we call congenial media. That means we can go to whatever media source we want and they're saying exactly what we believe in. And so when you look at the media, the sad truth is that certain media outlets are giving us false information about climate change. Last year on CNN, 30% of the information about climate science on CNN was false. That's on CNN. On Fox, over 3/4 of it was false. So we're being fed false information. And that's why there's this huge bias. And so I believe that when you look at other social justice issues in the past, when you look at slavery, who was at the forefront of slavery? Anybody seen that movie Amazing Grace? Awesome. Christians were right there. Why are Christians not on the forefront here? Don't we believe God created the earth? Yes. Don't we believe he gave it to us? Yes. Don't we believe we're to love others? Yes. There's no theological issues here, and so I think we should be on the forefront. We've just been listening to the wrong people. We've been letting our politics inform our faith, in a nutshell, instead of our faith inform our politics. Thank you.
That's a great place to close, and let's give and also you plug your Facebook page, so I'm going to plug, we have created a Houghton page called Houghton Climate Caretakers. If you're interested in staying informed on climate issues, particularly as how it connects with faith or justice issues,